relational data model. So we already complete the conceptual modeling, which is the ER entity relationship model, which is based on the identifying the entities as well as identifying the relationship. Then we little bit extended to the EER model that cover the super and subclasses relationship. So these are just the conceptual modeling. So our goal in this class is to build a database system on a computer. Computer is totally different from the human being. So when I explain about what is a student, what is the teaching, what is the instructor, all of you guys can understand. However, computer cannot. Because computer use a different language, different thing that is called the data structure. So we should have something new data structure that can understand our conceptual model. So to address that problem, we started last week about the relational model. Okay, so relational model is the database model, which is different from the conceptual modeling. So don't be confused. So conceptual model, ER modeling it's just a conceptual model, high-level model. It can be used for any application, even not only for the computer application, but it can be used for your organization, anything. Then we will build a database on a computer. To do that, we need a new data structure, new concept of the data, a set of the rules that can understand our conceptual model that is called the database modeling. There are a bunch of different database modeling. For example, network modeling, hierarchical modeling, and object-oriented database modeling. Among them, we select the relational database model, which is based on what? A set. It's a mathematical concept. Okay, we regard a set of data as a set, a relation. It's a relation. So relation is a formal term in relational database model, which is equivalent to the table in informal. I think that you guys are familiar with such an informal term. Okay, so I will use the informal term and the formal term interchangeably throughout the semester, so you should understand the both of them. So, for example, the attribute is the property. So, it can be column in informal term. And row is the tuple in the relational database model. And the domain is the value of column and so on. So this is just the example of the student relation. Eventually, this will be table in the database. Okay? So, but somebody may be curious, what is the Oracle? What is the DB2? What is the SQL Server? In terms of what is a relationship? How to relate it to the relational model and the DBMS? What's the difference? What is the Oracle?
Software.
It's a software. Okay? Just like the Excel, just like the Word file, MS Word, just like the other software running on the computer, it's a software. For what?
To retrieve the data
To manage the data, right? Then, when somebody, so you can implement, you can make your own DBMS software. But to do that, you should have something blueprint, like your design, right? To make what is that design of the worker? It's a relational model. So Oracle, when Oracle was developed, the developer, those who make the Oracle, they consider relational model to build the DBMS software. What about the DB2 or SQL Server? They are the same. They are using the same model, same concept. It's a relational database. As long as they follow the DBMS use the relational database model, that is called Relational Database Management System, RDBMS. In other words, if you know how to use the Oracle, it's not a big deal to catch up other relational database model. Why? Because they are using same, the concept, same origin. So sometimes there are research area like the linguistics. Linguistics, sometimes they try to find which languages are sharing the same origin. So some of the languages are very similar. So when you can speak, for example, the which languages are quite similar?
Spanish.
The French and then the English are not much different. Some of the words are the same. I'm not expertise in the linguistic history, but it's the same idea. So if you can use the Oracle, the DB2, other DBMS, it's not a big deal. So that's the reason I do not cover all the DBMS software. Oracle is just an example software. Okay? So, but last class we just taste what is a relation only. There are a bunch of other concepts. Okay? Rule and the data structure in relational database model. So we learned about what is a relation. Relation can be defined as what? Group of data. Because what is a set? Set is group of elements. Right? It's a group of, it's a big jar that has a bunch of the elements. It's the same thing. The student relation, student table, student something is the bunch of students inside. It's a group of students, which is called sometimes tuple, sometimes row, sometimes data. It's a group of data. Or we can use different way, like the attribute column. Group of attribute, group of column. This is another definition of the relation. So when we are saying the relation or the table, you can explain about the table or the relation by showing all the data, all the tuple. Or you can, student has name, ID, address, and so on, attribute. Either way is fine. So that's the reason we can define the student table as the name, SSN, home phone, address, then GPA. Or Bayer, Ashley, Davidson, Cooper, and Benson. However, it's true, most of the current DBMS, relational DBMS system focus on how to access data. But nowadays, it's also important how to access column data. I gave you already example of the such column-based data, like the, for example, sensor. So you have the 1 million of the sensor nationwide in United States. Every day, so you collect the data from 1 million sensors. So you have the 1 million of column. Then every time you got the data of temperature, for example. So at that time, you don't need all 1 million of the data, sometimes specific column. Even finding specific column from the 1 million sensor, it's not easy. But nowadays, most of the company and current database has many data rather than number of columns. But number of column-based approach is also important. Okay? Then we need to discuss about the specifics, the characteristic of the relation. What is a really relational database model? So there are 3 constraints. What is a constraint? Actually, it's a restriction or rule or condition. So in other words, so to be a relational database model, that model should satisfy with this kind of constraint. These are not the only constraint, but major constraint in relational database model. Some of the concepts you already know, whether or not you learn in the relational database model, or the others are not. If you have such a background or the fundamental thing, when you learn the other database model or even the relational database model, it's easy to understand why we have the key, why we have the foreign key. You don't have to worry about what, even though you do not know what is a foreign key, we will learn. Okay? So that is a constraint. First one is a key constraint. You know what is a key. We already discussed about the key in ER modeling, right? What is a key? In terms of the ER modeling, conceptual modeling. Key attribute. It's a unique. In other words, using that attribute, you can identify specific entity, right? That is the key attribute. How many key attributes? Only one for each entity? No. You can have sometimes many key attributes, like the employee entity may have SSN as a key attribute, also employee ID as a key attribute. What are sometimes named? There are a bunch. Sometimes you can have the 111. Sometimes you cannot have the key attribute. Why? It's just conceptual model. It's not the database model. However, in relational model, each relation should have the one key attribute. That is the key. We will see what is the key. First. For example, we have the employee relation. Employee relation have the employee ID attribute, SSN attribute, name attribute, address attribute. Each attribute can identify specific data using which attribute. For example, employee ID. Using the employee ID, you can identify the data, right? So employee ID. What else? SSN. Using SSN, you can identify specific employee, like the one-on-one. You can find your employee having the specific social security number. Any others? No? What about employee ID plus SSN? Can you identify specific employee? Yes, you can do that. Others? Employee ID plus name. Employee ID plus address. Employee ID, name and address. Or social security number, name, social security number, address. So you can have many combination of. It's a key attribute. It's called a super key. Super key is a set of attributes that can identify specific data. How many super key? You can have many. It's not infinite, but you can have the finite number of the super key. Okay? Even employee, such a small relation, may have bunch of super key. Among them, do you need such a all the combination of the super key? I don't think so. We need minimal super key. Minimal super key means we don't need the name, we don't need the address, we don't need the combination of that, only employee ID and social security number as the key attribute to identify the data. At the time, these two keys are called these keys. Sometimes one, sometimes two, sometimes three. But it's a minimum super key. We don't need the other. It's called the key attribute. Key attribute. How many key attributes? Just like the ER model, it can be one or more. Okay? If there is no key, that cannot be relation. It's different from the entity in ER model. So we can have two of them. How many presidents in United States? It's one, right? How many the chair in the department? It's one. How many king of the nation? One. So how many son? It's one. So key attribute, if we have the two key attributes, it will be complicated. Especially for computer, as I mentioned many times, computer is dummy. If we provide two keys, computer will be confused. So we need to select one of them as
primary.
That's called the primary key. So primary key means one key that can represent each relation. So that is the reason it's called a primary key. Not just key, it's a primary key. How many primary key for each relation? It's one, only one. Anytime it's one. Not zero, it's one. So primary key is the only one for each relation. What about, so I select the employee ID as the primary key. Then, what about the other key? It's a key almost, right? Foreign key is a foreigner, right after we select the primary key. No, it's called a candidate key. We have many candidate key. What's the difference between primary key and candidate key? No difference. It's almost the same. But primary key is selected as two representative of the relation. It will be used for the main key, primary key. That's the reason it's called primary key. The other will be candidate key. Both of them are very important to find the data. Okay? So that is the key constraint. First rule in the relational model is a key constraint. Key constraint is there exists only one primary key for each relation. Okay? So then it's a unique. It should be unique. So primary key definitely should be unique. Did I explain about the null data? Null data is, for example, when we define the student relation over here. So we collect all the students, like the Davidson, Benson, and so on. Then each relation, each element should have the same format, same attribute, like the name, social security number, home phone, address, office number, age, and GPA, right? However, for example, sometimes Davidson does not have a home phone. So we rule out, eliminate the Dick Davidson. Is it fair? No, that's only one missing data, right? Even that is a home phone number, not very important. So instead of eliminating such a data, we would like to keep it. How can keep it? We can assign null data. That's called a null. What does that mean, null? Null is a zero? No, it's not zero. Null is something not? No, null is null. Doesn't exist. Just like do you know this symbol?
Yeah.
What is that?
Empty set.
Empty set. What does that mean, empty set? Nothing.
Nothing.
So it's not like this one, right?
Yeah.
It's just nothing. So probably you got a bunch of time this kind of question. Which is the difference? Right? The number one is this, number two is this, and number three is this. This is the set, right? It's existing this one. So null means not NULL. NULL is the data. But when we are saying the null, it doesn't exist. Where? Why? We'd like to keep home phone attribute. All data should have the same structure, same format, right? To keep such a missing data, we can use null. It doesn't mean NULL or whatever. It's a null, doesn't exist. Nothing you can find. So that is null. So we have the data. For example, so let's do it this way. The set A is a unique one. Is a unique? Unique or not? Yes, a unique. There's no tree. Okay? It's a unique. So 1, 2, 3, you can identify the data. What about this one? It's a unique one. What does unique mean? You can identify the specific data using 1, 2, 3. Yes, no. It's a unique still. What about this? Another null. It's a unique one.
Not unique.
Not unique.
Why?
Because it's double null.
So they are the same.
Yes.
However, does it make sense to compare not existing thing? Is it NULL? No, it's not existing. Actually, in the world, there's no this one. That means even we cannot compare, it doesn't exist. Okay, still unique. Do you understand? So, null is very unique data, really. It doesn't exist. It's not zero, it's not nothing, it doesn't exist. So, we cannot even compare. It's the same as 1 to 3. Okay? So, that means, what if primary key should be unique? If, let's say social security number is a primary key, we select this one. Somebody does not have social security number, so NULL. Is it still unique? Yes, it's still unique. It can be key attribute, primary key attribute. However, can you find the null data?
No.
Especially when you have the many null, you cannot identify, you cannot search specific data. So it's, even though it's a unique, you cannot search the data. To address that problem, the next constraint is entity integrity constraint. That means primary key should not be null. Okay? That is a reason. I think that you already hear about the definition of the primary key before. Primary key should be non-null and unique.
Yes.
That is the reason why primary key is non-null and unique. Okay? So some of the DBMS suffer the unique constraint. That means it allows null data. However, primary key constraint, primary key means non-null and unique. That's the difference. Usually the candidate key allow non-null sometimes. Okay, that is the entity integrity constraint. The next one is the last. So far, the key constraint, entity integrity constraint deal with a specific at the one entity, one table. In one table, we try to find the primary key representative. We try to define the characteristic of the primary key, the non-null unique. The next one is referential integrity that involves two relations, two tables. For example, we have employee. We have department. Then employee, we select social security number as the primary key. Primary key can be underlined. Okay. Then we have name, address. Also we have department information where this employee is working. Also department, we have department ID and
Name.
Department name and location. Something like that. Department ID is the primary key of the department relation table. Okay. Then, so we have the department 1 and name HR, department 2, payroll office, and so on. We have the employee 111, name is Lee, and address, and department is, for example, I'm working for HR, and 112, so instead of HR, so I try to use the ID. Okay? No problem. And 112 employee, the James, work for payroll office. No problem, right? What if there's another? So, for example, John is a new employee, then mistakenly. So I did a mistake, like some new 100 department, which doesn't exist. Any problem to create such a database?
Yes.
Systemically, technically, no problem, right? Even though as long as I follow the rule of the primary key, it's okay. You can create the table, you can create the table. However, in terms of the requirement of this company database, 100 doesn't exist here. It doesn't make sense. So how can we keep such a rule, concept? We need to specify the department information by the department table. In other words, department information should exist in the department table, department relation. It's a rely on this one, like this way. Okay? This is called foreign key relationship, or sometimes it's called a referential integrity. It's a referenced column, referenced attribute, referenced table, referenced the relation. This one is referencing. So referencing, reference. The reference one should be unique. Usually it's the primary key. Why? If you have the multiple one, you don't know which one is which, right? That is the reason reference one should be unique. Usually, mostly is a primary key. That makes sense. So you can create such an integrity constraint that is called a referential integrity or foreign key constraint. That is the most important creative idea of the relational database model. What about the network model? What about the object-oriented model? What about the other database model? They do not have such a thing. Because of that foreign key constraint, it can keep the consistency of the data. Okay? This data is limited by the disk. Very strong rule. You need to check every time you insert the data, this one. Also, because of that, your data will be non-redundant data. You don't have to keep the department information over here. Instead, whenever you need the department information, you can use a foreign key, then get the data. Even though you have the 1 millionth of the department one, you need only one data in here. That is foreign key constraint or referential integrity constraint. Very, very important. However, in real-life system, probably some of you guys encounter the same problem. Many of the database ignore foreign key constraint. Think about your database, the programming project in other classes. You create a table. It's very easy. Just one line. Create table and table name. Sometimes you forget the primary key, but it's suggested, recommended to create the primary key, so you can keep the primary key like the social security number, certain number, ID. Then that's it. No problem to run the database. Then why many people ignore this one? It's a very, very strict constraint rule. Okay? For example, sometimes I have a new employee who are not assigned any of the table. Can you do that? No. You should have temporary even the data, because it should must rely on the department reference table. Okay? So very strong rule. Sometimes I need to delete this table, then recreate. Yes, you need to do that. It's called a reorganization. Like in Windows system, you need to do the defragment, right? Defragment, you can, so if you already took the operating system class, it's a page. You can remove the empty page by recreating, rewrote all the process again. It's the same thing. So you can recreate the table. At the time, if you delete this relation, what happened? No information. So it will be disabled automatically. Okay? So also, I create the two tables, so I'd like to insert the employee table data first. Can you insert this data without this? So not easy. So it's very hard to manage the data. So, however, without this one, everybody insert any data, so your data will be very dirty. It's called the dirty data. Okay. So this is a foreign key constraint. Let me explain. So we can use the underline to represent the key attribute. Okay. How many candidate keys? It can be many. Sometimes not. Okay. How many primary key? Only one primary key in the table. This is one of the examples of the car. There's a primary key, is a license number, and so on. Then relational database schema. What is a schema? We use a lot. Schema is it's kind of description. So relational layout is the same thing. Description. So when we are saying the database schema for the universe database means all the table, all the integrated, all the things that are needed to create a company database or the university database. That is called the database schema. So database schema consists of a number of relation tables. So that relation should follow this integrated, three integrated that we discussed. Any question? I know. I will bit speed up because we already missed one of the class. Huge snowstorm. I never seen such a huge snow. A couple of years ago, around Connecticut, we got I think the tri-state area got the huge snow, but at the time it was I think the half of this, but back to back. So for back to back, the big snowstorm, but not like this one. It's one time. So almost 4 inches. It's 1 meter. Can you believe I shoveled by myself my driveway? Okay. Then other types of constraint. The 3 constraints are not all the constraints. There are many others constraints, but they are minor. Okay, which means when you build, I'd like to make the new DBMS system, relational database management system, to compete with Oracle. At the time, you can adapt the primary key constraint or entity referential constraint. Also, there are many others. Sometimes can be optional, sometimes the mandatory. One of the examples is a semantic integrity constraint. For example, my rule, I have some restriction of the data constraint, like the salary should be less than 10K. It's too small. So 100K, for example. It's my rule. Okay? So at that time, is there any way to keep such a data? Such a customized constraint, customized condition can be implemented by, it's called the trigger or the assertion. Okay? So you will use such a customized constraint, which is called the trigger, for your first project. In the first project, you will use such a customized constraint in your first project. I will explain the details about the first project later. Eventually, our goal is to build such a database schema. This is called the company database schema, consisting of a bunch of tables or relations. So it has employee, department location, project, work zone, and dependent. Each relation has what? Primary key is underlined. For example, SSN, employee. D number in department. What does that mean? This. Does it mean the two primary key? No, it's a one primary key, but composite primary key. Composite means more than one attribute are involved. D number itself, no, it's not the primary key of this one. D location, no. D number plus D location is unique and not null. Okay? And P number, ESSN P number is the composite primary key. ESSN dependent name, composite primary key. Then we can have the data. One, database, relational database. Relation means a group of attributes. So it's okay in this database schema. However, what about the data? So we need to create the data, which is called actually population. So insert or create, it doesn't matter. So population, we need such a data. So data plus schema, which is called database state. This is the current state of the data. Our goal is to create the table, to create the relation, then insert the data. This is our goal in database design. How to conceptually design? Using ER model. Then using relational model, we can create the table relation on the computer. Okay? Does it work? No, not yet. What's the missing information? Relation? Relation? We have the relation. This is a relation. Foreign key. Foreign key is not here. Right? So we need to add foreign key, like this one. For example, super SSN, refer SSN. What does that mean? When we insert the data, supervisor SSN should exist in the SSN. What if? Can it be null? Super SSN? Can it be null or not?
Yes.
Yes, it can be null. It doesn't have to be non-null. Until not null constraint. You can specify the not null constraint. If you really want all the data for super SSN, you can specify it's a non-null constraint. Otherwise, it can be null. Okay? Who? What will be the example? CEO, right? It's an employee, but does not have a supervisor, right? Yes. Top of the employee tree. Okay? Like the family tree, your parents may not have such a parents, something like that. And we have a bunch of other DNO, refer, D number. ESSN, refer, SSN. PNO, this one. D number, this one, and so on. Okay? I have a couple of questions. First, in case, like for example, SSN and employee, for example, it doesn't have the employee ID, but let's say, oh yeah, this one. D name is unique, right? Department name. Also, D number is unique, which means we have two candidates. So I'd like to select the D number as the primary key. How can I select? How can I decide which one will be primary key among the many candidate keys? How? We need to decide one of them as a primary key. How?
If it's not null? If it's not null?
Yeah, both of them, not both of them, but yes, that's good choice.
I would think a number would be better because if you're using the letter, you might misspell the department.
Misspell also, yeah, that can be one reason. How many bits? Which one need more bit to represent the number and character? Usually character. Character should be converted to the number than binary. For example, the using ASCII code. Okay, it requires more bit. Yes, that's one another good reason. And is that all? The most important thing is it depends on. Depends on what? Application analysis. The database, why do we need a database? To support the application system, right? Your system, if your system needs a lot of the number, so number is the best way to access the data, then you'd better select the D number as the primary key. Even you can implement or you can use the D name as the primary key, but if your system uses the D number a lot, you'd better select. Another example is the social security number and employee ID. Do you know what is the social security number in the United States? It's the number for what? Only the registration? No, not everybody. It will be used for after you retired or when you got some problem. So if I lose the job, so I will get the benefit from the social security. Okay? As name implies, so for social security to survive here. Okay? Like the pension program. But it's a public pension program. Okay? So for example, if I die, the social security using that social, because I need to pay social security tax whenever I earn the money. Okay? What about the employee ID? Employee ID used for only company. So if your application program, your system is for company, at that time you'd better use employee ID rather than social security number. But on the other hand, if your application is payroll office, payroll is directly related to social security number because of the tax. At that time, you'd better use social security number as the primary. It depends. So there are many other reasons, but the most important reason is it depends on the application analysis. Who decide? You need to decide as a designer. There is no general answer. Okay? It's your job. But first time, not easy. Obvious thing, yeah, you can do that, but sometimes after you build the entire system, you realize D name is better. Your performance will be degraded. So when you design such a system, you need to decide which one will be better. And I had a couple of more questions, but I forgot. I will ask later when I remember. Okay? Oh, yeah. So, have you ever seen this one? This is called the database schema, right?
Yes.
For company, based on relational database model. Have you ever seen this before?
No.
But you can see, you already saw similar one from ER modeling. Somebody mentioned about, I understood. I recognize when you are saying the relation, when I asked what are the missing part, some of the students already answered. So relation, that is a relationship in the ER model, right? Quite similar. When we design the company database using the ER model, that is a conceptual model. We define the social security number, super SSN, to this one, for what? Relationship, right? So, for example, yeah, this one and this one, quite similar, right? Yeah. We are using different notation, different diagram, but it's quite similar one. This is a ER modeling, and this is relational modeling. So we learned about how to model conceptually from information which are not organized, but we organize conceptually in your mind or in your brain or sometimes in your note or in your application program like the Orange software. So you did. But our goal is what? Build a database system using DBMS. So we learned about the relational schema. So if we can create the table using the relational schema, that's it. The problem is, if you are asked to build a company database system, first you need to start to draw such an ER diagram. Then make the database schema diagram. Then create the database, right? But what we miss so far is we learned the conceptual modeling and we learned the relational modeling. What we miss is how to change this one to this one. Okay? That is called the converting the conceptual modeling to the relational database modeling. Okay? So that is the goal of the chapter 9. The mapping. This is very simple, straightforward way. That is the reason the title is just mapping. Relational database designed by ER and ER modeling mapping. It's just mapping, straightforward. How many steps? It has 9 steps. You can just follow the step by step. Before we continue this one, in relational model, actually, I'd like to change the operating system on my laptop to the Linux. It's Ubuntu. So I'm testing right now. So I'm very familiar with the terminal interface, command line interface, but not the graphical user interface on Linux. So that's the reason I little bit take a time to find the menu. This is, oh yes, this is the chapter 3. Anyway, so beginning. So we discussed most of the part of the relational model. But relational model, any database model does not explain only the structure of the data, such as the relation or some other data structure, but also database model show how to access the data. For example, when you are running object-oriented model, object is something. Then you can use or you can handle, you can access the data using method. So it explains how to access data, how to utilize such a data. It's the same thing in relational model. So you need to insert the data. You should be able to retrieve the data. You should be able to remove the data. That's called the data population. To do that, we can insert, we can delete, we can update the data. So we will learn how to access, how to manipulate the data in the database language. It's a SQL language later. Before that, chapter 3. This is chapter 9. Okay, so we will follow. So our goal is, so we have the conceptual model. We have the relational database model. We don't know how to create the table yet. That will be discussed in the SQL part, structured query language, with mostly exercise lab. Because you should be able to create. You understand from the modeling, but you should be able to create the table. That will be discussed in later. Okay, in the exercise lab. But what we miss is we have the conceptual model, we have a relational model. How to convert such a conceptual model to the relational model? We will follow such a thing for each object in our ER modeling. So we will start from the entity, then relationship, then super and subclasses. The first one is mapping regular entity type. What is a regular entity? It's a strong entity. Okay? Strong entities such as the student or the department or some employee. That is a strong entity. For strong entity, we can create just a relation. Okay? So that is the thing. Then, what we need is primary key in the relation. That's the rule. That's the model. We need one primary key. However, in ER modeling, we have many keys. Okay, key attributes. Among them, we should be able to one of them as the primary key. That's the job. So, for example, from this, employee can be what? Employee relation or employee table. What can be the key? So this time I'd like to select the social security number. Department, yes. So department can be table, department can be relation. What can be the key? So primary key can be name or number, but I decide to use number. Okay? And project, also same thing. And dependent, not yet. Why? It's a weak entity. Weak entity means it doesn't have the key, right? It disobey the rule of relational